All right, this is a video on completing the square, and we will also solve a quadratic equation just by taking square roots as well. But we'll start off with an introduction and then do a few different examples. So as an introduction, I just want to remind you that of the pattern that we see in a perfect square trinomial. Okay, so as an example, if we have this binomial that is being squared, if we were to FOIL it out, we would get x squared plus 6x plus 9. All right, and then the thing to be thinking about is relative to that 3 that I just highlighted, this 9 is the 3 squared, and this 6 is the 3 doubled. So that's a pattern you're going to look for. You're going to be looking for perfect squares like that. The pattern is a little bit more complicated if we have an a value that's not 1. In other words, if we might have something like this, 2x plus 5 quantity squared. If we were to FOIL that out, we will end up with 4x squared plus 20x plus 25. The thing to look for here when we have an a value that's not 1, so in other words, here the a value is 4, we want to look for a and c values that are perfect squares, and here they are, 4 and 25, right? That's a clue that this may be factorable into a perfect square, into the product of two identical factors. Okay, so those are just some things to look for. You're looking for the pattern of the number being doubled and the number being squared, the 3 doubled to get 6, the 3 squared to get 9. And then in the second one, you're looking for the pattern of a and c both being perfect squares. Some things to keep an eye out for. So let's go ahead and look at an example, and we'll look at some quite basic examples first, and then we'll actually end up with doing the completing the square process. So first we're going to solve some equations simply by taking square roots. And this first one, you can see that we have 3x squared equals 147. You might be thinking, if you want to do some factoring, maybe we need to subtract 147 from both sides, get things equal to 0. But in fact, in both of these, well, in the first one, since it's in standard form, there is no b value. Okay, so if we were to write this out, 3x squared minus 147 equals 0, there's no just x term, there's no bx term there. Okay, and for the second example, you can see it's written in something that looks similar to vertex form. Okay, so those are examples, those are the sorts of equations that we can solve when with square roots. So when b is equal to 0, there's a missing bx term, or if the equation looks to be in something similar to vertex form. So let's go ahead and solve these guys. And I think you can see first we can just divide, for this top one, divide both sides by 3. And we are going to get an x squared equals 49, which is nice and convenient. That's a perfect square. We will square root both sides. And remember, there are two different numbers that square to get a 49. Your calculator might only give the 7, but x can be negative 7 as well. Okay, both of those numbers square to be 49. For the second one, you might be tempted to FOIL out the x minus 3 to multiply it through and then distribute the negative 2. But since it's already in something that looks similar to vertex form, we can actually solve this with square roots. So we will first subtract 5 from both sides. And we get a negative 2 times the quantity x minus 3 squared equals negative 50. We can divide both sides by negative 2. And then we get x minus 3 quantity squared equals 25. And 25, again, is a perfect square. So let's square root both sides. And we're going to get what I call a double pathway. We have two numbers that square to be 25, okay? Positive 5 and negative 5. So one outcome is x minus 3 is 5, and another outcome is x minus 3 is negative 5. We can solve for x pretty easily. X here is 8, and x for the second one is negative 2. So those are my solutions. Negative 2 and 8 are the solutions to this equation. Let's make a little progress with, make it a little bit more complex and start thinking about what a perfect square trinomial might be. So as I alluded to earlier, if the first and the third terms are perfect squares themselves, or those coefficients are perfect squares themselves, you might think about, can this be factored into into two identical factors whose product is what we're given. So in this case, it can be. So this is going to factor into a 3x plus 2 quantity squared equals 0. Okay, we can square root both sides. And what we end up with is 3x plus 2 equals 0. 0 only has one square root. And we can solve for x from there, subtract 2 from both sides, then divide by 3. And x will be negative 2/3. So that would be our only solution to that equation. Now let's look a little bit at completing the square. So let me actually talk about what that actually means. So for the equation that we just solved, we were lucky because this 4 was a perfect square. But what if it was a 5 or a 2? What if all the other pieces of the equation worked out to be factored as a perfect square, but the 4 wasn't? Could we complete that square? Could we fill in some, maybe add something to it to force it to make it to be a perfect square? And so that's what completing the square actually is here. So my big suggestion first is to divide by a if needed, and we'll look at that example down the road. It's much easier to complete the square when our a value is 1. Shift the constant term to the right-hand side, leaving a blank for it on the left-hand side, okay? And we'll go through all the examples for this, but I like to get that constant term kind of out of the way so that we can then think about what goes in the blank to create a perfect square trinomial. And let's put that number in the blank, but we need to add it to both sides, okay, to keep our equation balanced. We can then factor it and solve, and it often works out pretty nicely and is a quick and efficient way of solving these quadratic equations. Completing the square will work more often than factoring, but if you get nice clean answers, you probably could have solved by factoring more quickly. So there's a sequence that I go through when I'm solving these. I first see if I can just solve by square roots. Then I see if I can factor. But I don't spend a ton of time on each. If either of those seem to be challenging, I might go to completing the square. And then ultimately, my last resort is using the quadratic formula. That's the most time consuming, but it's the most guaranteed to work. So let's solve this one by completing the square. And first, we're going to follow that first piece of advice by dividing by a. A here is 5. And so let's get rid of that 5. It's complicating things. And let's divide both sides by 5. So we're going to get an x squared minus 4x minus 21 equals 0. Okay, that may be factorable. In this case, it actually is factorable, but we're going to pretend that we didn't see how it's factorable. We're just going to go through the completing the square process. I'm going to add 21 to both sides and leave a blank for a c value. Okay, and now I'm thinking, what do I wish that value to be to make the left-hand side of my equation a perfect square? So looking back up here at the very beginning, it's analogous to thinking, what do I wish was in that blank right there to make that expression on the right a perfect square? And I am going to divide that 6 by 2 to get this 3, and then square it to get a 9. Okay, so we're going to go through that same process. We're thinking about what do we wish our c value was to make it a perfect square. Let's divide the b value, negative 4 by 2, to get negative 2, and square it to get a positive 4. Okay, so we are going to add 4 right here, and we need to add 4 on the right side to keep our equation balanced. So the left side factors nicely, x minus 2 quantity squared, and the right side turns into 25, which coincidentally is a perfect square. So we can solve by square rooting both sides. And we end up with x minus 2 equals, well, let me write my two pathways that I was talking about earlier. So this gives us two pathways. X minus 2 is 5, and x minus 2 is negative 5. And we can go ahead and solve from there. So x will be 7 or negative 3. So those would be my solutions. Again, we could have gotten this by factoring, but I'm trying to go through the completing the square process in a little bit less complex of an equation. Let's do another one. Again, we're going to get rid of our a value by dividing both sides by it to kind of clean things up, simplify things a little bit. Let's divide both sides by -2. So I get an x squared plus 6x plus 2 equals 0. Let's shift that constant term 2 over to the right side and leave a blank. So we're subtracting 2 from both sides. And then what do we wish that value was to make the left side a perfect square? We're going to look at the 6x, chop the 6 in half to get a 3, and square it to get a 9. So we are going to add 9 to both sides. We have to keep our equation balanced after all. Okay? And then we can write the left side as a nice perfect square, and we can simplify the right side. So now the left side is a perfect square, so we can square root both sides. 7 is not a perfect square, but we can work with that. That's okay. And so again, we're going to get 2 square roots. X plus 3 is equal to plus or minus the square root of 7. Okay. And our last step is going to be subtracting 3 from both sides, and I'm going to put that 3 out front. And I can write my answer like that. X is equal to -3 plus or minus the square root of 7. All right, I think we have one last problem to do. So another tool that you can use with completing the square, another use of completing the square is by taking an equation in standard form and writing it in vertex form. Okay, so remember, vertex form looks like this, with a the same in both vertex and standard form, and then h and k being the coordinates of the vertex. Okay, so what I'm going to do is get rid of that -7. It's sort of in the way right now, and so I'm going to rewrite my equation like so. I didn't move it to the other side, I just gave myself a space. Okay, and now I am thinking, for that piece of my equation, what could I add in right there to make it a perfect square? And I could add in a 4. I'm going to take that 4x that I'm given, chop the 4 in half to get a 2, and square it to get a 4. Okay, so I added 4 to the right side of my equation. Let's also subtract 4 from the right side of my equation to keep my equation balanced. I'm not adding 4 to both sides. I'm both adding 4 and subtracting 4 to the same side of my equation to keep my equation balanced. And let's simplify. Y equals x squared plus 4x plus 4 minus 11. So this is a perfect square. And then we have the minus 11 we need to include as well. So the vertex of this parabola is -2, -11, and we have an answer in vertex form. All right, we did it. We got through it, and that is a good place to stop.